Next will be a joint presentation. Chris Hazelwood, Global Promotion Manager, Factory Automation. He has 25 years of experience with Mitsubishi Electric. He established the e-factory concept in Europe. And the speaker with him is Mr. Chetan M. Gohil, Manager Technical Services, Industrial Services, FAG Bearings India Limited. Gohil is a veteran practitioner of reliability engineering. He has 16 years of field experience. Chetan has been actively involved in various projects in the heavy industries spanning such markets as steel, cement, power, pulp, and general process plants. Chetan is an expert in reliability and conditioning monitoring solutions. Please welcome both speakers onto the stage.
So basically, I'm very happy to be here in India. This is the second conference I've attended here. And I have to say, it's one of the most well attended with delegates. So it's a pleasure to be here and to see so many good faces. So let's see if I can work the magic. Basically, you know probably the name of Mitsubishi. It's famous for cars and Bank of Tokyo and many different things. But Mitsubishi Electric is a specialist in electrical and electronics manufacture. We were established in 1921, and we have a turnover of about 4 trillion yen. So that's quite a bit. So I want to talk to you, actually this is really nicely following on to the ABB presentation. I want to talk to you about what happens when it all goes wrong. When everything is, it's been a bad day and you've got your head in your hands and oh no, what's happened? And basically, probably something like this has happened to all of you, or at least your plant managers, when the machine has just stopped working. And maybe a few minutes before, you had some smoke coming out of the machine, and a few days before that, somebody noticed the machine was getting a little bit warm, but nobody did anything. A little bit sad, really. A while before that, there might have been some noise. You might have heard some strange knocking noise or some squealing where there's a lack of lubrication in the system, and you're thinking, oh, I'll fix that later. But it's already too late. But actually, you had a warning signal even before then. Way, way back, even weeks and months before, you would have had some invisible warning signs, vibrations. The machine started to do something it shouldn't have. And why was that? That was because something went wrong. Something you didn't see went wrong with the machine. Because before then, everything was happy. Machine was running great. Production was fantastic. So wouldn't it be nice if we had an early detection system? In this case, we're showing a vibration monitor. Well, if we could act earlier, we could save money. If we could save money, we could avoid problems at delivery and all these other kind of things that knock on from the lack of availability of the machine. Such a system, of course everyone knows, is called a CMS. CMS, Condition Monitoring System. These have been around for a long time, but all this Industry 4.0, IIoT, have actually made CMS become something much more powerful than before. Because we're able to actually bring data in context with the situation and start to understand a little bit more about the real information that we're seeing. So what kind of inputs come into the CMS system? Well, we have some reactive inputs. We could look at, for example, how many production items we made. So we know something's going to wear out after producing a certain number of items. It could be we're drilling holes with a drill. After 100 holes, we know that the drill is beginning to wear, and the accuracy of the hole is no longer reliable. It could be that actually we could look at the machine process data for more live information. If we looked at the current on the motor that's driving the drill bit, and we start to see the current increase, we know the drill bit is probably beginning to wear. So we now have two pieces of data we could put together and start to build a picture. There are, of course, some external factors, such as environmental data, things that are not necessarily under 100% of our control. Temperature, humidity, other factors that we might need to consider. And we have some expert systems, such as a vibration monitor or thermography, or some of these other more high-tech ways of looking at things. So we put all this data together, and we need a way of collecting it and bringing it into a way that we can analyze it and interpret it. So we need an infrastructure. We need a layer of agents and connectivity. Could be networks, it could be just looking at data sets, many different ways, depending on the inputs. So with our classic factory automation, we can be looking with a field bus or with Ethernet. With condition monitoring systems, we may be able to pull data wirelessly, or we may have dedicated protocols to talk. And we have databases we can pull data sets from and look back over history and see what happened before. There was a mention again in the ABB presentation about experts and historical knowledge. We have stored experts and historical knowledge. And we have that environmental data. We know, for example, with an injection molding machine, we need a longer cooling time if the environmental temperature is higher. So we know our production rate will be slightly slower. So once we got all the data together, we actually need to put it somewhere. So we put it into a database. And some people say that database is a cloud, and that cloud is remote, or it could be local, or it could be on a machine. Frankly, it doesn't matter. It's a place where you consolidate information, and you review it, and you get answers from it. So that's a basic architecture, a basic overview. It's a preview to what we're going to hear from Schaeffler. We're going to look at 3 different case studies, because one of the things that concerns us is that whenever we hear the discussion of IoT, Industry 4.0, everybody's thinking of big systems, big companies, with SAP, ERP management at the top. But actually, this is equally scalable and important for small companies as well, and small devices. So we're going to start with the first case study, which is actually a water treatment plant. And that water treatment plant is unmanned, and it just has 4 pumps. Very small. It's a device scenario. The next we're going to look at is a paper mill. And this paper mill is a single machine, but it's huge, 4 stories tall. It's making paper on rolls which weigh about 9,000 kilograms. It's a single machine, but it's a big machine. And then we're going to look at actually a multinational. We're going to look at multi-site, pulling all data together, so completely scalable. And the other way we're going to look at this data is it's not limited to discrete manufacturing. It applies to process, it applies to hybrid, as well as discrete. So it's scalable in a different dimension. And I wrote here local cloud, plant cloud, and private cloud, because I want you to understand that everything doesn't have to reside in the big WWW. You can still protect your data, you can still control your local information, but you can use those concepts. So I'm going to hand across to my friend Chetan from Schaeffler, who is actually an expert in vibration. Thank you.
Good afternoon. So, as described by Mitsubishi, we are going, basically I am Chetan from Schaeffler Group, FAG Bearings, and in beginning of presentation there was something about Mitsubishi E-Factory, and under that they have many partners, and one of the partner is Schaeffler Group. So Schaeffler Group, at Schaeffler Group we have huge setup, huge understanding, competency for reliabilities. And after joining hands with Mitsubishi, it's now better and better. So in this forum, we selected 3 cases where, as explained by Chris, we are going to discuss 3 different case where how the condition monitoring or how the monitoring will be useful. So So regarding applied condition monitoring, before I start discussing each case, I was just listening the presentations, and I found 2-3 words very common in many of the presentations. These words are smart. It may be a smart sensor, smart machines. Then intelligent. Another word was connected, interconnected, and obviously cloud. So I am very happy to say that in our presentation many of the things are covered, and it is also mentioned that how it is practically implemented in actual life. So this is about my company, Schaeffler. That's FAG bearing is a part of Schaeffler, and we have many company like you can see here Luke, INA, FAG. These companies you may be familiar. And in India, the industrial division of Schaeffler has one of a service unit where we are working on reliability engineering. So let us start with the first one, where waste water treatment plant is there, and the company is somewhere in Germany, in Rosenberg, and this company is processing water, and that wastewater treatment plant is unmanned because very small, and it's not possible that someone can be there for permanently. So here the equipment which was there is pumps. These are screw pumps which you can see over here. Oh, sorry. You can see here screw pumps are there. So these screw pumps transfers slurry, I mean some water and something from here up to this discharge point. And these screw are being driven by using one geared motor, and it works 24/7 continuously. So when this history of this equipment was analyzed, it was that it was going under breakdown with any not a fixed intensity, sometimes within 1 year or sometimes within 3 years, and it was not so fixed. So due to that, time-based maintenance or preventive maintenance was not possible, or rather it was not giving any good result. So if these pumps are not working, it will affect at least 20,000 people in the village. So to improve the reliability of the machine, we installed our sensors. It is Smart Check, FAG Smart Check. So since this is a compact system, we put one Smart Check per machine. So likewise 3 Smart Checks were there, and all 3 Smart Checks were connected by using Ethernet, and this Ethernet was further connected with some Mitsubishi controller and through internet. So here at this setup is a field on water processing plant, and from here these data are being sent to one central server or central monitoring system where the data are being monitored, and in case of any abnormality, it triggers that something is going on wrong. And not only by using computer, but it was possible to review the data by using some external device like laptops or mobiles or any smart device, and we get the information. So after this, the reliability of the system was improved very much, and another thing was all investments are associated with ROI, that is return on investment. So that calculation also was carried out, and the actual scenario was overall of the gearbox, it was taking at least 1,000 euro, and new gearbox was 5,500 euro. And the solutions which was implemented was having some cost of 5,700 euro. So practically if we avoid one failure or more than one failure, then we get a payback. So initially it was estimated that at least 1 year or maybe 2 years or sometimes 3 years there should be a ROI. So estimator was identifying more than 2 gearbox, and if we avoid failure of 2 gearbox, then the advantage is saving of 3300 euros, and the main important thing is failure of avoiding 2 failures of the gearbox, and that affects 20,000 people. When this system was installed, within 4 months one defect was identified. People went there, did the maintenance, and the condition was restored. So here the thing is, as Chris said, it's not so big system where so many complexities and everything is there. It's very simple system where local network was created and data were pushed to somewhere, and they were getting all the information about the machine. This is the second case, that is regarding Mitsubishi HighTech paper. This is a paper plant which is having 1730 meter per minute speed, and this is really a very huge speed. If you see, convert these into speed, it is 103.8 kilometer per hour. So you can imagine one high speed car is moving. So at this speed, paper is moving in the plant. So since this is a longer high speed, so dryer section of the plant will be longer. So this is about the plant, and here you can see a picture where these peoples are there, and it's a 4-story plant. So just to give you understanding that how the big system is and where it will be useful. So the target was total 26 fans are there. So out of 26 fans, 13 are fans, blowers, and rest 13 were extractors. So these were pushing the air, and other 13 were taking the air and sending it off. So here also, if you see, in case of breakdown of any fan or any blower, the paper will not be able to get dried to the required level, and that will give say stoppage to the production, and sometimes the entire paper roll that will go into the scrap. So it's a big loss of money as well as production opportunity. So here the system required was a little bit different than what we saw earlier. Here we have installed 26 smart checks, so 13 on blower and other 13 on other, and all these smart checks are connected on site by using PoEs. So that is power over Ethernet. So PoEs help you to reduce the cabling works. You don't have to make some connection for power and some connection for data and all. No, single cable, it will take care for everything. This system was connected with a central system by Ethernet cable, simple, and entire. So by doing this communication, all the smart checks, they were available in a same network and from any centralized PC. By using FAG smart visualization, we can see what is happening with which fan. So the condition of the fan will become red, yellow, green. So it's very easy for the operator. Just see the condition yellow, then ask some maintenance guy to attend it, and he has to see that it once again regains to yellow, yellow to green. So overall setup was like this. Another beauty over here is there was one installation of smart controller from Mitsubishi, and this system can communicate with the existing controlling system. So here these all sensors are getting information about the plant operating condition through this channel. So since already all the informations are available, so our system smart check, it need not to get all the data by putting your new sensors or like that. Already informations are available, and these two systems are communicating and they get data over here. So it is an example like how two systems can communicate with each other, and we get better and better reliability. So when this was installed, here some statistics are there. The cost of one roll is 12,000 euro, and the cost of the complete 26 sensor was 25,500 euros. So here also ideally more than 2 identification of the damage will give the payback, and apart from this more than 10,000 euro of saving was there. But in overall the key point or the information about the system is, if existing system is there and we want to make the equipment smart and interactive, then it's not so difficult. Just put some small sensors, connect it with some processor, and it is possible to achieve. So this is a little bit complex than what we saw in earlier. The third one is even more complex. That's our own example, because we also believe and agreed that yes, condition monitoring or reliability based maintenance is very, very necessary in all the fields, whether it's a production or continuous operation or whatsoever. So here at FAG Germany, we have a manufacturing plant, and in this plant some data are there, like 77,000 square meter workspace, more than 3,500 employee works round the clocks. So that indicates about how big the plant is. So here we decided to implement a completely predictive maintenance concept. That will help us not to just identify the bearing or machine condition, but it will also help us to maintain the production quality. Like in one of the one of the example from Chris, it was mentioned that say if drill machine is there, it makes some say 100 drills, then yes, we have to change the drill bit. So if the thing is, if it is not changed, so it will give high vibration, so that will give additional forces on bearings, so bearing will get deteriorated, and on the other hand, whatever production this drill is doing, that production will not be up to the required quality. So in that way, vibration can help not only in manufacturing process, but in some production process also vibrations are useful. So here once again the thing is a little bit different from what we saw earlier. Here we have put smart checks on machines, and this smart check will have different kind of inputs. One possibility is by TCP/IP connection, one possibility is by analog inputs, say some signals are not available, and simply it can pick up any 4 to 20 milliampere and it can be fitted with smart check. Sometimes we have digital switch box from Schaeffler, and this switch box can handle many of the data plus power and everything. So everything was combined at field level. At controller level, we have storage facilities, some controlling system from Mitsubishi, communication, and also clouding. So this what we do with process of data. At upper level it is MES. So MES is manufacturing execution system by means of SCADA and FAG Smart Visual. So here it takes care about monitoring of all the machines, and then it is connected to ERP levels, means SAP. So here the overall system is, in case of any abnormality, the complete process can trigger a work order, and that work order defines that what is the problem with machine, it is unbalanced or misalignment or whatsoever, and that will generate one work order that maintenance department has to execute. So this on full-fledged system, how it works. So here the advantage are really it's a priceless, because you can understand, so if a bearing, if it is not up to the mark and it goes to site, then if it is not performing, then that will give deterioration in the brand image, as well as the cost to replace this bearing is very, very huge. It's not cost to us, maybe it may be a cost to customer, but ultimately is it a cost. So the reliable processes it gave, and that is really priceless. And now we are going to implement such kind of predictive maintenance program all over the world, and even in India also we have already implemented in all our 3 plants, Luke, INA and FAG. So about future, this system, this interesting, this is what we can say, it is a small representation of industry 4. So here you can see in this machine or gearbox, we have a detect X1, that is once again a vibration monitoring system. We have lube oil monitoring system, and we have some auto lubricators also. So when this system is running, it will measure vibration, measure the parameters, it will feed it to crowd, so anyone from anywhere can see the data. And the beauty of the system is, in case of say the instrument, it is a smart instrument, it understands vibrations are from what? If it is from bearing due to lubrication, then it will take input from auto lubricator, or and it will ask the one work order to replace the oil. In case of bearing is having problem, then it can give signal to auto lubricator to feed more grease. So now here once again, based on machine condition, the instrument has triggered a work order to another instrument to carry out the lubrication, and the complete process is automatic. Going to next level, these all machine data can be fed to one of our software, Bearing X. So here the Bearing X identify what is the forces on the bearing and till how much time the bearing has already run, and based on that it will calculate the remaining life of the bearing on continuous basis, and that will give feedback to the complete system that bearing at this location has already run to 65% of the life and 75% of the life, like the presentation in ABB. So yes, likewise system is also in place at Germany. And lastly, all things we discuss is related to one fixed plant or one fixed say setup, for example plant or any machinery. But such kind of system is also possible in moving machines like train. In case of Japan, it is very famous for high speed train. So in Japan also we have installed these smart checks in trains to monitor what is the condition of bearings of the wagon. And here also, since it's moving, so cloud connectivity is must, and in case of any abnormality we get information through cloud in a monitoring center, and that they can take the preventive action so that this machine or this wagon do not see any unplanned or online failure. So that is from my side regarding 3 case studies. I will request Mr. Chris once again to...
Okay, thank you for that, Chetan. I just wanted to come back and just say a few words at the end, because what we wanted to do today was to show you not the concept of Industry 4.0 or IIoT, but show you the reality. You know, we're not talking about theory. We're not talking about what might happen in 1 year or 6 months or even 2 or 5 years' time. We're talking about what's happening now. What's possible now. What you can implement by yourself with small steps. It doesn't have to be an all or nothing experience. And one of the key points is this element here. The word collaboration was mentioned several times earlier today, and collaboration was probably meant between systems. But there's also collaboration between partners to help implement systems. And if those partners have lots of experience, and for us, our concept has been running since 2003. So this is well established and is well proven because we're using it in our own factories as well. The point being, with over 3,000 different partners, any type of solution is pretty much deliverable. And we're not trying to say you must use a certain type of partner. You choose what you need to use, as you would do in any normal supplier situation. But the point is, you can do these things today. You don't have to wait, okay? There are lots of open technologies out there that you can utilize. There was a comment this morning in the ARC CEO's presentation. We need more open systems. Yes, of course we do. But all of you here have established factories or operations. That means you have pretty much all brownfield sites, which means you have legacy things you need to talk to. And we need to talk more about how to communicate with the legacy systems, because you're not going to throw your factory away and build a new one. That's ridiculous. So yes, we need open and seamless systems, and we need good ways with good partners to actually deliver that. And we're not the only ones. There are plenty of good partners here today, and you can see them in their own exhibition area as well. So definitely encourage you to speak to people. And there are lots of people with know-how. And sometimes the companies with know-how aren't always the biggest companies. There was a presentation about startup companies and about innovation and about coming up with new ways of doing things. We shouldn't ignore them. They are very much helpful for tomorrow. So these concepts are complex, but with small steps, we can actually make them realities. In Japan, we call this Kaizen. So this Kaizen process allows you, empowers you to make the solutions for the future. So we talked about preemptive maintenance today, but there are other areas that you will be thinking about. And you won't be thinking about technology. You'll be thinking about your business need. I need to track and trace. I need to manage my renewable energy resources balanced with my standard energy consumption. So we're on the edge of a very exciting future. What a great time to be in manufacturing. Thank you very much.